so far. Okay, you are quite familiar because you have been doing assignments where TCP and UDP protocols are involved. But you do not know so far how these two protocols function. So this philosophy of the functioning of these two protocols we are going to talk about over here. Today we are going to just get an introduction, but after that in the next classes, that means next week, basically further details we are going to look into. So the full form of TCP is Transmission Control Protocol. It is not Transport Control Protocol. Okay, so many times I ask, even like PhD students also, they make this mistake. Yeah, so Transmission Control Protocol is the full form of TCP, and it is a connection oriented protocol. Already we spoke a while back. Meaning of connection oriented, that means the connection has to be first established, then data transfer, then connection tear down. So it is this kind of protocol. And because it is connection oriented, it is reliable also, right? It is not a best effort kind of service. All of you are able to hear me clearly, right? Okay. In case somewhere you are not able to understand, you ask me to repeat, I will tell you. Or you can even come over here also in the front bench. So TCP uses the GBN and SR protocols. What is GBN? That culprit, right? Where you lost lot of marks, 7 marks. GBN. What is that? Go back in. Because of that GBN only you lost marks, right? So it is that protocol and the selective repeat. Okay, these two you know. So this GBN and the SR protocols are used to provide reliability in TCP. Acha. So to achieve this goal, basically TCP uses this checksum. This also you know, the checksum mechanism. Exactly the same thing that you learned earlier. So this checksum is used for error detection, retransmission of lost or corrupted packets, cumulative and selective acknowledgements, and timers. So these are some of these different features that TCP uses. So some of these we are going to cover over here in this class, and others are kept out of scope. TCP offers these services: process to process communication, stream delivery service, we spoke, full duplex communication, you understand, half duplex and full duplex, you know, right? Anybody has doubt about what is full duplex? Very good. Multiplexing, demultiplexing we covered. Connection oriented service, reliable service, you know everything by now, what these terms mean. Now TCP uses a numbering system. Now this TCP software, it keeps track of the segments that are being transmitted or received, and there is no field for a segment number value in the segment header. So there are two fields that are there. One is called the sequence number, the other one is called the acknowledgement number. So this TCP numbers all these data bytes that are transmitted in the connection, and this numbering is independent in each direction. What does it mean, independent in each direction? So TCP, what it will do, I will show you shortly. It will number the segments, the bytes that are transmitted from client to server using a certain sequence numbers, using a certain set of sequence numbers. And in the other direction also it is going to use another set of sequence numbers which is independent from the first set of sequence numbers. Okay, so in both the directions, basically independent sets of sequence numbers are going to be used in order to keep track of the bytes that are transmitted. Okay. The numbering system does not necessarily start from 0. TCP uses an arbitrary number between 0 to 232, 2 to the power, this will be 2 to the power 32 minus 1 for the number for the first one. So whatever. So This is 2 to the power 32, not 232. Acha. Now, what is this sequence number? The sequence number is very important and integral to TCP. You need to understand the sequence number very well. So, TCP, after the bytes have been numbered, TCP assigns a sequence number to each segment. So, every segment is going to have a sequence number. The sequence number in each direction is independent, but how is the sequence numbering done in every direction? The sequence number of the first segment is the initial sequence number, which is basically a random number. So, from left to right, first sequence number is a ISN number, and that ISN number is a random number. But after that, the sequence numbers that are given to the rest of the segments, that basically can be tracked from the first sequence number with the number of bytes that are transferred. So, the sequence number of any segment afterwards is the sequence number of the previous segment plus the number of bytes that are carried by the previous segment. Is it clear? Doubt? So, when the segment is sent from left to right or even from right to left, so let us talk about left to right. For every segment that is sent, because it's a reliable service, you need to get an acknowledgement back. So, how this acknowledgement numbering is done? This acknowledgement number, so each party uses an acknowledgement number to confirm the bytes that it has received. Now, the interesting thing is that acknowledgement number is little peculiar in TCP. This acknowledgement number is the number of the next byte that the client, the party, expects to receive. So, from the left to the right, I will show you a diagram which will make it clearer. But for now, just know the theory. So, the segment is sent, acknowledgement is sent back. So, when the server is sending an acknowledgement back to the client, it is also stating to the client that not only I have received such and such segment number, but after that which segment I am expecting to receive. That is also encoded in that number in the acknowledgement. Now, you see that why, you might think like, okay, so if I just simply acknowledge, that is sufficient. Why do I need to keep track of what is the next one that I am trying to receive? So you might think about that. It is because the acknowledgement numbering is cumulative in TCP. What does it mean? What is the meaning of cumulative? The party that takes the number of the last byte that it has received, safe and sounds, adds 1 to it and announces this sum as the acknowledgement number. So, whatever last byte I have received, I add 1 to it and I send it back, piggyback with the data in some cases, because TCP allows that. And then whoever has received that acknowledgement knows that the other party is expecting which particular segment. Okay, so few more details. Now, this segment basically, it can be divided. This is the segment, right? This is the data part of the segment and this is the header part of the segment. In TCP, the header part is 2260 bytes. Because there are options, etc., which can also be given, right? Options are optional. So if you give the options, basically, the size of the header will increase. So this is the header structure of TCP. Have a very clear-cut look at the header structure. Source port address. What did you have in IPv4? Do you remember? After a few fields, you had the source IP address, destination IP address. Remember in IPv4 header structure? Here, not IP address, but the port address. Source port, destination port. So source port address 16 bits. So this is what I was telling you earlier, 2 to the power 16 minus 1. The source port address, destination port address, sequence number, 32-bit sequence number, right? So basically the sequence numbers will be from 0 to 2 to the power 32 minus 1. Same goes for the acknowledgement number also. Then comes H length, header length. Same philosophy like before when we were covering the IPv4 header. The purpose of the header length there and here the same thing. Because until you specify the header length, the receiver doesn't know that how far is the header and when the data part starts. So you have to specify that this much is the header. So this is where you specify the header length. Then there are few reserved bits. And after this, these are some special fields that are there. URG stands for urgent. We'll talk about it. ACK is for acknowledgement. PSH is for push. RST is for reset. SYN is for synchronization. FIN is for finish. These are some of the flag fields. These are called flag fields. So that means that if the sender, for example, is sending some data which should be treated as urgent, then this urgent flag is going to be set. If the sender is sending some data, some packet, some segment, which is indicating that now the connection has to be terminated, so this fin field flag is going to be set like this. So these are some of these flags. Window size for sliding window, checksum for error detection, few urgent pointers and options and padding. Okay. So you have the source port address, destination port address, sequence number. So this is 32 bit field. Okay. And TCP is stream oriented protocol. To ensure connectivity, each byte has to be transmitted and it has to be numbered. The sequence number basically tells the destination which byte in this sequence is the first byte in the segment. So during the connection establishment, which we will discuss shortly, each party uses a random number generator. You know what is a random number generator, right? Everybody knows random number generators. Huh? RNGs, everybody knows. Okay, very good. So they are going to use a random number generator to create an initial sequence number. So this initial sequence number in every direction will be generated randomly and is going to be independent of each other because they are purely independent random numbers produced using random number generators. This acknowledgement number, again a 32-bit field, defines the byte number that the receiver of the segment is expecting to receive from the other party. If the receiver of the segment has successfully received byte number X, then it returns X plus 1 as the acknowledgement number. Now, in some cases, I will show you, we will talk about it again. Acknowledgement and data can be piggybacked together. That means that client sends some segment, some data to the server. Server acknowledges the receipt of that particular data, plus it also piggybacks that acknowledgement with the piggyback means that jod diya ek saath, so together. So piggybacks the acknowledgement on top of the data that it was actually supposed to send to the client. In some cases, if it has data to send, it will piggyback with the acknowledgement. TCP allows it. Header length, 4-bit field indicates the 4-byte words in the TCP header. Length of the header can be between 20 to 60 bytes. Therefore, the value of this field is always between 5 and 15. 5 times, so you have to multiply by 4 like before. For IPv4 also the same thing. So that will give you the actual size. of the header. So these are these control flags that we were talking about, control fields or flags. What are these? URG is for urgent, ACK is for acknowledgement, valid or not, PSH is request for push, RST is reset the connection, SYN is for synchronizing the sequence numbers, and FIN is for terminating the connection. Now this window size, this field basically defines the window size of the sending TCP in bytes. So the length over here is 16 bytes, 16 bits. So the maximum size of the window is 2 to the power 16 minus 1, which is 65, 535 bytes. So this value is normally referred to as the receive window size or window, receive window. Remember, very often we will encounter this R window, C window, etc. R window is receive window size. So who determines this receive window size? The receiver determines the receive window size. Receiver. Checksum, as I said, is for error detection. Like before, in the case of framing also the same thing we did, use of checksum. So 16-bit field contains the checksum. Use of the checksum for TCP is mandatory because it is reliable, right? It's a reliable protocol. It also has to, guarantee that whatever is being received is basically correct. So checksum, and so that for the TCP pseudo header, the value of the protocol field is so whatever. So forget it. So this is basically the header format for TCP. Okay. Now, let us now try to understand this connection oriented feature in TCP. So first, the connection has to be established. So what it will do, TCP, it will help in establishing a logical path between the source and the destination. Logical, that connection has to be established, so that all the segments that belong to a message will be sent over that particular logical path. So using a single logical pathway for the entire message basically facilitates the acknowledgement process as well. TCP uses the services of IP to deliver the individual packets to the receiver. If a segment is lost or corrupted, it is retransmitted. Unlike TCP, IP is unaware of this transmission. So these two bullets, let us try to understand. TCP runs on what? IP. IP is connection oriented or connectionless? Connectionless, right? So IP is unreliable, but TCP is reliable. TCP runs on IP. You understand? So do you remember when we talked about IPv4? So there we talked about that the header part basically the integrity of the header part will be done through the help of this checksum mechanism. But the rest of the part, the reliability of the part is not guaranteed. The actual payload, basically that part, the reliability of it is not guaranteed by IP. IP is an unreliable protocol. It doesn't guarantee that. So at that time, if you recall, I mentioned that IP depends on the layer above, that means the transport layer, to have the option of either having a reliable protocol ensuring the reliability of that part, or you can use something like UDP where you leave it open. Do you understand? Is this clear? So basically IP depends on TCP to ensure the integrity of the data that it has received from TCP for the actual part. But the header part, basically it will do its own error detection, etc., using the checksum field that is there in its header. So if a segment is lost or corrupted, obviously it has to be retransmitted, because it's a connection oriented reliable protocol. So unlike TCP, IP is unaware of this retransmission, because it is between these two layers. IP doesn't have to be involved in this. If the segment arrives out of order, then TCP will hold it until the missing segments arrive, and IP will be kept unaware of this particular thing, because TCP is handling at its own level. In TCP, the connection oriented mechanism requires 3 phases: connection establishment, data transfer, and connection termination. This is the most important part of TCP. 3 phases, 3-phase mechanism. One is connection establishment, data transfer, and connection termination. So what is this connection establishment? This connection establishment is to establish the connection between the sender and the receiver before actually the sender tries to send the data. So first it has to establish the connection. So it establishes the connection using this 3-way handshaking mechanism. Many times this is a very important question actually in transport layer. You will be asked like, explain the 3-way handshaking mechanism in TCP. So this is where this part you will have to explain. 3-way handshaking in TCP is a very important topic. So first, the server program will tell the TCP that it is ready to accept a connection. By doing so, it does passive open. So client, server says, I am ready. So passively it is making it open. Okay. So this is called passive open. So these are technical terms, passive open. The server does passive open. So although the server is ready to accept a connection, but it cannot make the connection by itself. To do the connection, basically it needs to take help of that some client which will make the connection. So then only if the client program tries to establish the connection, then it has to send that active open request to the server. So passive open, then active open. So client that wishes to connect to a open server, because the server had already made it passive open, right? So the server is open. So this client which wants to connect to that open server, it tells its TCP to connect to a particular server. And now the TCP can start the 3-way handshaking process. This diagram try to understand very, very well, heart of everything. So let us try to be attentive and try to understand how it works. So we have this scenario: client, server, client process, client transport layer, server transport layer, server process. Client process wants to communicate with server process. Okay. So first you see that first the server process is going to initiate the passive open. First the passive open is done. Then the client process basically will do an active open. Then what do these transport layers do? Once the passive open and the active open are done, then this client transport layer, it is going to send this particular segment from the client transport layer to the client server transport layer. So this segment has all these fields that we talked about little while back, the TCP headers, right? One of which is the sequence number. Sequence number field is there. Sequence number and few other fields, and then you remember there were these flags, right? Like the control flag, this urgent flag, reset flag, finish flag, etc. So one of these flags basically is about the synchronization. So synchronization flag is going to be set like this, S. So this is called the SYN packet or the SYN segment with the S flag set, which is sent from the client to the server. Now notice over here that sequence number is the first sequence number, which is the ISN, initial sequence number. This initial sequence number is what? A randomly generated number. Only the initial one, rest of the ones are not. So you see that 8000 is the sequence number, which is the randomly generated one. So the server receives it. The server then sends the another segment back, where you see the data as well as the acknowledgement, these are piggybacked. That means, so here what the server does, it also has the server segment, basically it also has the initial sequence number, which is independent from this random sequence number that the client had sent. So this was random number 8000, this is another random number 15000. It also does, you see, it acts, acknowledgement is set to 8001. So this sequence number that it had received, it will add 1 to it, as I said before, and it is going to send it back. So 8001. So now this fellow knows that the server has received till 8000 and is expecting the sequence number 8001. Same thing over here. This guy was 15,000 received by the client. It is going to send the acknowledgement with 15,001, implying to the server that it is expecting the next segment to be 15,001. So this is how the connection is opened through the three-way handshaking process. One way, second way, third way. This is called the three-way handshaking process for connection establishment in TCP. Very important. Okay? Doubt? Clear? Now, you see, this is just a side note. Oh, who has a class? Somebody has a class, right? In another 4-5 minutes, you have a class, no? Okay, so let us see, how far. So this one, basically, I will not go through in too much of detail, but this the SYN flag, basically, the SYN packet that is sent, that can actually lead to some kind of an attack, denial of service attack. This is just a side note that, this sort of thing basically also has its own, side effect, right? So there is a denial of service attack that can be done with the help of the SYN flag. It is called the SYN flag attack. SYN flag attack. It's a security thing, not too much important, but you should know at this stage that there is something like this. So connection has been established. Now the data transfer has to take place. So data transfer basically is bidirectional. The acknowledgements are piggybacked with the data. The data segments are sent by the client. The data segments that are sent by the client have the push flag set, so that the server TCP knows to deliver the data to the server process as soon as they are received. Because the client is pushing, server knows, PSH is set, that immediately you send the data to the server process. The sending TCP uses a buffer to store the stream of data coming from the sending application program. The sending TCP can select the segment size. The receiving TCP also buffers the data when they arrive and delivers to the application program when the application program is ready. Is it clear? Easy. Data transfer is not difficult. So ultimately what is happening over here, you see all these A flag, acknowledgement flag, P flag, push flag, these are sent, data are sent also along with this. Then the receiver side also, so like this. Now you see this receive window. Receive window means that the receiver window size, how much it can accept. Because ultimately the sliding window protocol has to take place, right? So it announces that this much of data I can accept. Same thing over here. You see this receive window size is announced by the client also. Urgent bit, so you go through yourself, nothing, not a big deal. This part is important again. Connection termination. So for connection termination, there are two mechanisms that are used. One is called the three-way handshaking, like before for connection establishment. The other one is called four-way handshaking with a half close option. Two mechanisms for connection termination. So first of all, what is this three-way handshaking? So you have this active close. First, the client process which wants to no longer send any data, it will do active close. Then basically, so the rest of the things are very similar, but over here you see the fin flag has to be set, because now it has to indicate that I want to finish the data transfer. So the fin flag is set. So then it acknowledges with this corresponding acknowledgement field set and the fin flag set, and finally, so the acknowledgement corresponding to this acknowledgement that was sent from here is sent from the client to this thing. Then only the connection will be. So you see, first is the active close, then is the passive close, and then is the connection. Finally, the connection gets closed this way. So this is the three-way handshaking mechanism for connection closing. The other mechanism is the half close mechanism. This is basically four-way. So 1, 2, 3, 4, four-way mechanism for connection close. Again, active close. Okay, like this. Server. Data segments from Acha. Now the interesting part. Client initiates active close. That means that client doesn't want to transmit anymore, but it leaves it open for the server, that if server wants to send something in between before the actual closure is done, it still has the flexibility to send the data to the client, to which the client is going to acknowledge also. Do you understand the half close? Half close is because that the client has initiated closure, but the server still has some data to send. So server sends, client acknowledges, and then after that, once this passive closure is done by the server also says that, okay, now I also want to close. And then, the corresponding, this thing is done. The FSMs, corresponding FSMs will give you better idea about the different states through which the server and the client goes through. The client states and the server states. You go through yourself. If in doubt, it is actually taken from your book only. So go through the book. In case you still do not understand, always you can come back to me. Not a problem. So that's all. Any doubt? So some of the important concepts actually of transport layer were covered today.